All right, in this video, what we're going to do is we're going to talk about what happens to the alpha. Okay, this is the third video under the arbitrage pricing theory topic. What we first talked about was that any inefficiencies, when I say inefficiencies, I mean profitable risk-adjusted investment opportunities. So we say that this is the relationship between risk and return, and here exists two profitable investment opportunities. We can buy stock E that's going to give us some risk-adjusted profit, and we can short stock F that will give us some risk-adjusted profit. But what's going to happen when we begin to trade on these inefficiencies? These things are going to converge back down towards this line so that any risk-adjusted profitable investment opportunities are going to be arbitraged away. That's what happens there. We also talked about what happens to the idiosyncratic risk in a portfolio. So as we start to buy up these, inefficiencies or these risk-adjusted profitable investment opportunities, and our portfolio gets large enough, what happens is, as the portfolio is well diversified, the limit as n goes to infinity, n is the number of assets in the portfolio, it can be showed that as the limit of the idiosyncratic risk as n goes to infinity goes to zero. In other words, a well-diversified portfolio will have no idiosyncratic risk. So I'm arbitraging away all of the inefficiencies that exist in a risk-adjusted basis. I'm diversifying away all of the idiosyncratic risk. What happens to the alphas? Okay. So we talked about this in the single factor model as well. Let's say there's two portfolios, portfolio 1 and portfolio 2. I've estimated these things. What did I do? I took the historical returns minus the risk-free rate. I have some measure of systematic risk. I ran a regression and I fit a line that best fits that data. I have an intercept alpha and a slope of beta. Okay, so this is the estimation of portfolio 1. Likewise, I plot data, the second set of data, okay, historical return data for asset 2, portfolio 2, whatever you want to call it, on systematic risk. Notice that the slopes of the lines of portfolio 1 and portfolio 2 are similar, but notice that the alphas are different. Okay, so what's going to happen? I'm going to prefer to buy portfolio 1 and I'm going to prefer to sell portfolio 2. And because of that, not only are the inefficiencies of individual assets arbitraged away, but entire portfolio alphas will be arbitraged away. That is, I'll prefer portfolio 1 over portfolio 2. The excess demand for portfolio 1 will create price premiums in subsequent underperformance. Likewise, the lack of demand for portfolio 2, because it has negative alpha, the lack of demand is going to produce underpricing for portfolio 2 and subsequent overperformance until these two things eventually converge and alphas are now arbitraged away. Okay? So arbitrage pricing theory is very straightforward. I didn't even need to use math here to discuss what's happening. The arbitrage pricing theory basically states that any individual risk-adjusted profitable investment opportunities are going to be arbitraged away. Idiosyncratic risk will be diversified away in a well-balanced portfolio or a sufficiently large portfolio. And all alphas will be arbitraged away, such that the only thing that matters are these systematic risk events. All right? So hopefully these 3 videos have helped you understand what arbitrage pricing theory is trying to do. In the next section of videos, what we're going to do is we're going to talk about what we call multi-factor models, where we're going to try to better identify what systematic risk is. In one case, we're going to build upon the capital asset pricing model and add additional risk factors. And in another case, we're going to use some macroeconomic data to come up with what we call a multi-factor model. Okay, so stay tuned.